welcome to the third video in our 5-part series on surds. In this video we're going to talk about the other or some more surd arithmetic, and we've done simplifying, so we're going to bring it together with addition, subtraction, multiplication and division. Now in this case, as with fractions, you may remember, multiplying and dividing is actually easier. It's the addition and the subtraction that's a little bit trickier, and we'll start with the addition and subtraction and then we'll go on with the multiplying and dividing. So let's start by having a look at some examples, and we will be relying on some of that simplifying stuff. So let's look at A. The square root of 2 plus 3 root 2. Now this is where I really want to emphasize to you that in this case root 2 is a thing, and so the square root of 2 represents one of those things, and 3 root 2 represents 3 of those things. So we have 1 root 2 plus 3 root 2, which gives us a total of 4 root 2. It's really important that you treat it that way. You recognize it's a thing. Another example that would be very similar would be, what is x plus 3x? And that of course is equal to 4x. That's how root 2 is treated in this instance. Example B. Root 8 minus root 2. Now here I want to emphasize the idea that you need to have like surds. So remember that, like surds. Now we can't do x minus y algebraically, and we have that issue here. Root 8 is different to root 2. They are not like surds. So what do? If you get in this situation, anytime there's not like surds, you should be thinking, can I simplify any of them? Now, root 2, I can't simplify. It's really as low as it's going to go because 2 is such a low number. But root 8 can be written down as root 4 times 2, which is 2 root 2 minus root 2, which is a little bit like 2x minus x. So I'll write that down here. And that, of course, is equal to x. So 2 root 2 minus root 2 is equal to 1 root 2. And 1 root 2 is just root 2. You don't have to have that 1 in front. And so there's our answer. And you can check that in a calculator. So if you're doing these questions, just check them in a calculator. You'll get an irrational number, but you'll know if they're the same. Is root 8 minus root 2 the same as root 2? Calculator says yes, so you're happy. C. This one's a little bit longer. Root 72 minus root 75 plus root 5 minus root 24. Now just keep in mind as we're going here that this negative travels with the root 75 and this negative travels with the root 24. It implies that those things are being subtracted. So if we move those around, the negative travels with them. Now I can see how I've got no like surds, so I'm going to start by simplifying any surds I can. Now 5 is a prime number, so I know I can't simplify that. 72, I go back to my square number list and I can see that 72 is the same as 36 times 2, and 36 is 6 squared, minus 75, which is the same as 25 times 3. 25 is 5 squared, plus root 5 minus 24, and 24 is the same as 4 times 6. So I've got, and 4 is the largest square number I can take out of it. And so now I come out with this. 36 times 2 is 6 root 2 minus 5 root 3 plus root 5 minus 2 root 6. Now let's have a quick look and highlight some parts. This is a root 2 term. There are no other root 2 terms. This is a root 3 term. There are no other root 3 terms. This is a root 5 term. There are no other root 5 terms. And this is a root 6 term. There are no other root 6 terms. There are no like surds in here. So this is quite similar to saying 6x minus 5y plus z minus 2a. There are no like algebraic terms. There are no like surd terms, and I can't do any more with this question. Now let's move on and talk about multiplying and dividing. So I'm going to continue my example numbers, and we'll call this one D. Let's have a look first of all at root 3 times root 6. Now we talked briefly about this in the last video. If you're multiplying surds, you just multiply the values. 3 times 6. And it's that simple. So the rule here is that the square root of a times by the square root of b is equal to the square root of ab. And in the last video we used this but in reverse. We would split it up once we found our square factors, which is much like what we did here, but this time we're just going to combine them. So this, of course, is the square root of 18. And we should always be simplifying. So are there any square factors here? Yes, there are. So there is a 9 times 2, which is 3 root 2. So that can be simplified down to 3 root 2. And example E. 3 root 7 times by 2 root 21. So in this case, we have 3 times root 7 times 2 times root 21. And let me write it out like that, just to really emphasize things. Now you don't need to remember this term, but in our number system that we use, number multiplication is commutative. And you don't have to memorize that term or know really a lot about what it means unless you move into specialist maths. But what that means is that 7 times 3 is the same as 3 times 7. And that's really helpful in this case because I can change the order to be 3 times 2 times root 7 times root 21. And that makes it easy to see that I just multiply the whole numbers to give me 6, and I multiply the surd to give me the square root of 7 times 21 is 147. So I've got 6 root 147. Now I do my check again. 147 is 49 times 3. And 49 is 7 squared, so I get 6 times 7 root 3, which is 42 root 3. You may have noticed, and it doesn't matter if you didn't, but you may have noticed that there's a root 7 here, and that this can be written down as root 7 times root 3. And root 7 times root 7 is just 7, and then we're left with a root 3, which gives us 7 root 3. So whilst I'm going through this in a bit of a laborious way that sets up a really distinct procedure, you might find some shortcuts to some questions just through logical reasoning and thoughtful thinking. Now let's look at example F. And in example F we have root 21 divided by root 7. And this is the same as multiplication. It's quite simple. It's the square root of 21 over 7. Which of course you know is the square root of 3 because 21 divided by 7 is 3. So we have this. The square root of A over the square root of B is equal to the square root of A over B. That's the general rule. And finally, example G. In example G we have root 6 times 2 root 12 over root 2. And so this is the 2 just multiplied by the 1 outside the root 6 times by root 12 times 6 over root 2. So this is now 2 root 72 over root 2. Now I can bring those surds together using that fraction rule. So that is 2 times root 72 over 2. Just have to be careful about my notation there. That 2 makes it look like it's part of the square root. So I should have it like this. And that is 2 root 36. And hopefully you can see that 2 times root 36 is 6. And so that's equal to 12. And again, just put this into your calculator if you want to check your answers. Moving forward though, in an external exam there are components that don't have a calculator for that. But while you do have a calculator, you can check your answers quite easily. And so that's the end of video 3. All the best.